Hydroelectric power plants convert energy. How do we calculate this? We use this specific formula. These are the parameters. Let's solve an example.
The water stored at a height possesses potential energy. When released through a penstock, it gains kinetic energy and rotates the turbine. The turbine drives the generator to produce electricity.
This is the most important formula used in hydroelectric power calculations. Head is the vertical distance between the reservoir and the turbine. Flow rate is the volume of water flowing per second. Efficiency accounts for turbine, generator, and mechanical losses. Multiplied together, they give overall efficiency.
Let's look at numerical example 1. Use this formula to calculate the power. This gives 44,100 watts, which is 44.15.
Let's calculate the generated power. We are given 150 meters of head. Multiplying flow, gravity, and efficiency, the power is about 108 megawatts.
Prolonged drought conditions severely impact our ability to generate power. Water flow variation directly reduces the volume available for the turbines. Manley's hemicescence.
Power generation in a hydroelectric plant depends mainly on head, flow rate, and efficiency. Using the formula P equals ρgQHη, and